Welcome to Sleepy Science, where stories drift across the quiet horizon, where science softens into calm whispers, and where your mind can fade gently toward deeper calm. If you enjoy peaceful journeys like this one, remember to subscribe and tap the like button. Your support keeps our little corner of the cosmos glowing gently in the vast quiet of the night. Before we begin, share something with us in the comments. Where are you watching from? And what time is it right now? It is always magical to see how many places drift together into the same calm moment. Now breathe in, slowly. Let the day soften behind you. Let the dim light settle around your thoughts. And allow yourself to drift into a quiet journey about the story of Earth's oceans. A story that begins not with water, but with fire, darkness, and the early trembling heart of a young planet. Long before Earth shimmered with blue oceans and soft waves, it was a world shaped by heat, a place where the surface glowed with molten rock, and the sky was filled with vapor so thick that sunlight struggled to reach the ground. The earliest Earth was not calm or cool. It was a sphere of liquid stone, drifting through the quiet space of the young solar system, wrapped in an atmosphere that felt heavy and warm. Imagine looking at this early world from above. There are no clouds shaped by wind, no oceans reflecting sunlight, no calm horizon where sky meets water. Instead, the surface flickers with red and gold, like a vast sea of glowing embers. Volcanoes rise and collapse in slow, powerful motions that reshape the crust almost continuously. Everything moves with the deep rhythm of a planet still forming itself. The atmosphere above this molten landscape is thick with gases released from within the planet. Water vapor rises in enormous amounts, carried upward by the relentless heat. Carbon dioxide fills the air. Traces of nitrogen drift in slow currents. This atmosphere holds heat tightly, preventing the young planet from cooling quickly. From space, Earth looks like a shimmering ember wrapped in a glowing shell of vapor. Despite the intense heat, something important is happening inside the planet. As the crust shifts and volcanoes breathe out vast clouds of gas, Earth's interior releases water that had been trapped within minerals since the planet first formed. This water rises as vapor into the sky, joining the thick atmosphere that surrounds the world. Imagine this atmosphere growing heavier with each volcanic plume. The sky becomes a deep, dense curtain of steam. Sunlight filters through in faint, warm rays. Earth spins beneath this blanket of vapor, holding within it the future of every ocean, lake, and river that will one day shimmer on its surface. Far out in space, icy comets drift through the young solar system. Some of them collide gently with Earth, adding more water to its growing reservoir. These icy visitors melt instantly upon impact, releasing their stored water into the already thick atmosphere. Each collision adds to the potential for oceans, layering future liquid into the heavy sky above the molten ground. But the surface remains far too hot for rain to fall. Water vapor cannot condense. Clouds cannot cool. The young Earth must wait. Slowly, through long stretches of planetary time, the surface begins to lose heat. The molten crust thickens. Volcanoes become less constant. The atmosphere holds its moisture high above the planet, gathering potential with each passing moment. This is the world just before the first ocean forms, a world wrapped in vapor, glowing softly beneath a heavy sky. A world preparing for a transformation that will bring calm water to its surface and shape the future of life itself. Let this image settle gently into your thoughts. Feel the heat fading. Feel the vapor gathering. Feel the quiet approach of rain that has not yet begun to fall. As time moved forward in its slow and patient way, Earth began to change almost imperceptibly. The fiery surface that once glowed endlessly started to cool. The molten oceans of rock thickened into darker, heavier crust. Heat still rose from within the planet, but it no longer dominated every moment. Above this cooling world, the atmosphere remained dense and heavy, filled with vast amounts of water vapor, waiting quietly for the right conditions to transform. Imagine the sky of early Earth during this transition. It is not blue. It is not clear. It is a deep, dim canopy of steam and gas stretching endlessly around the planet. Light from the young sun filters through this thick veil, softened and scattered, creating a muted glow that never fully brightens the surface below. As the planet cools, something subtle begins to happen high in the atmosphere. Water vapor starts to lose energy. Tiny droplets begin to form. At first, they are fleeting, appearing and vanishing as temperatures fluctuate. But slowly, steadily, the balance shifts. Condensation becomes possible. Clouds begin to gather for the first time. Not the gentle drifting clouds we know today, but massive, towering formations that wrap around the entire planet. These clouds grow thicker and darker as more vapor condenses within them. Gravity waits patiently, and when the droplets grow heavy enough, the sky finally releases them. Rain begins. Not a brief shower, not a passing storm, but rain that falls continuously for ages. Warm rain pours down through the dense atmosphere, striking the hot surface below with a steady rhythm. Each drop hisses softly as it touches warm rock, briefly turning back into vapor before the cooling crust allows more water to remain. Picture this rain falling across the planet. No thunder, no wind shaped by forests or mountains, only the soundless descent of water under a dark sky. Rivers begin to form, not from springs, but from the endless rainfall carving paths across fresh stone. Water flows toward low regions, collecting wherever the surface allows it to rest. As the rain continues, the surface cools further. More water remains liquid. Shallow basins fill first, forming wide, warm seas. These seas connect slowly, merging into larger bodies of water that spread across the planet. Steam rises gently from their surfaces, drifting upward and returning to the clouds above. The cycle becomes self-sustaining. Rain falls. Water gathers. Heat escapes more efficiently through the liquid surface. Cooling accelerates. More vapor condenses. The oceans begin to take shape. Imagine standing at the edge of one of these early seas. The water is warm and dark, reflecting only dim light from above. The surface is calm, disturbed only by the constant rain. There are no waves yet shaped by wind, only gentle ripples spreading outward as drops meet the growing ocean. Above, the clouds drift slowly around the planet, carried by early atmospheric circulation. Below, water deepens and spreads. What was once a world of fire begins its transformation into a world of water. As you imagine this endless rain, let its steady rhythm soften your thoughts. Each drop falls gently, one after another without urgency. Let your breathing match this rhythm, slow and calm. Feel the warmth fading, replaced by deeper calm as water settles across the surface. This is the moment Earth learns to reign, a quiet turning point where vapor becomes liquid, and the foundation of all oceans begins to rest upon the planet. As the rain continued its long and patient descent, Earth's surface began to change in quieter, more structured ways. The cooling crust was no longer smooth or uniform. It bent, cracked, and slowly settled into varied shapes. Some regions rose slightly, others sank. These gentle differences in height created natural basins, shallow at first, then gradually deeper, where water could collect and remain. Imagine the planet from above during this age. The sky is still heavy with cloud. The light is dim and diffuse. Across the surface, dark patches of liquid water appear, scattered like reflective mirrors embedded in stone. These patches grow slowly, not rushing, not spreading wildly, but deepening as rain continues to fall. Gravity guides every drop. Water flows along the easiest paths, tracing lines across the young crust. It pools in low regions and lingers there, cooling the rock beneath it. As the rock cools, it hardens. As it hardens, it holds water more effectively. The surface and the water begin to shape one another in a calm exchange. These early basins are not yet oceans. They are warm, mineral-rich seas, shallow and wide. Volcanic activity still releases heat from below, warming the water gently. Steam rises in thin veils, returning moisture to the sky. The cycle of rain and evaporation continues, steady and unbroken. Over long stretches of time, the basins connect. Water spills from one low region into another. Channels deepen as flowing water erodes the soft crust. Separate seas begin to merge, forming larger bodies that stretch across great distances. The first outlines of future oceans quietly emerge. Imagine drifting above one of these expanding seas. The surface is smooth and dark. There are no waves shaped by wind yet, only slow movements caused by temperature differences and the steady inflow of rain. The water absorbs heat from the planet and releases it upward, helping Earth cool more efficiently. With each passing age, the balance shifts further toward stability. Beneath the water, minerals dissolve from the rock. Iron, silica, and countless other elements mix into the sea, enriching it. These minerals give the water weight and depth, preparing it for the complex chemistry that will follow much later. For now, the oceans are simply becoming. They are forming space. They are settling into place. Above, the clouds remain thick, but begin to thin slowly. As water moves from the sky to the surface, the atmosphere loses some of its heaviness. The pressure eases. Light becomes slightly brighter, though still soft and muted. The planet feels calmer, quieter, more balanced with each passing moment. Picture the soundless rhythm of this world. Rain falling, water flowing, heat escaping, rock hardening. Nothing interrupts the process. Nothing hurries it forward. As you imagine these gathering waters, let the idea of settling deepen within you. Feel thoughts flowing toward quiet places in your mind. Feel them collecting gently, becoming still. Let the steady formation of Earth's first seas guide you toward deeper calm, where nothing needs to move quickly, and nothing is unfinished. The water has learned to stay, and in staying, it begins the long, quiet work of shaping a planet. As Earth continued its slow cooling beneath a sky that was still heavy but gradually thinning, the countless basins scattered across the surface began to merge into something far greater than isolated seas. Over immense stretches of time, these connected waters spread until they formed the first true global oceans, vast and dark, wrapping the young Earth in a continuous layer of liquid calm. From a distant view in space, the planet began to change its appearance. What was once a glowing world of stone now appeared darker, smoother, and quieter, as enormous bodies of water absorbed sunlight and softened the planet's harsh edges. The surface reflected only dim light through the thick atmosphere, creating a muted shimmer that hinted at the oceans below the clouds. These early oceans were warm, far warmer than those of today, because heat still escaped from Earth's interior, and because the atmosphere retained much of the sun's warmth. Yet, despite this heat, the water brought a profound sense of balance to the planet. Liquid water absorbed energy during the day and released it slowly, preventing extreme temperature swings and helping Earth settle into a more stable state. Beneath the ocean's surface, the seafloor remained active and restless. Molten rock rose through cracks in the crust, forming underwater volcanoes that released heat and minerals directly into the water. These slow eruptions did not shatter the calm, but instead created long ridges and gentle slopes along the ocean floor, shaping the earliest structure of the planet's basins. As hot rock met cooler water, minerals dissolved and spread, enriching the oceans with elements that would later become essential for life. The rain continued for ages, but it slowly weakened as more water moved from the sky to the surface. Clouds began to thin, allowing slightly more sunlight to reach the ocean's surface, where it diffused softly through the water, creating faint gradients of light and shadow. The ocean surface itself remained mostly calm, because winds had not yet developed strong patterns, and there were no continents or mountain ranges to shape the movement of air. Imagine floating above this early ocean, watching its immense surface stretch endlessly beneath a dim sky, with no clear horizon and no familiar colors, only deep, dark water gently exchanging heat with the air above it. The planet feels quieter now, more settled, as if it has exhaled after a long period of fiery tension. As oceans expanded, they also played a critical role in Earth's chemistry. Carbon dioxide dissolved into the water, reducing the thickness of the atmosphere and helping the planet cool further. Chemical reactions began to occur between water and rock, locking carbon into minerals and stabilizing the climate over very long timescales. This quiet interaction between ocean and crust laid the groundwork for the planet's long-term habitability. The presence of vast oceans also marked a turning point in Earth's story. Water, once suspended entirely in the sky as vapor, now rested on the surface, shaping the planet through erosion, heat exchange, and chemical balance. The world was no longer dominated by fire and steam, but by liquid calm and slow transformation. As you imagine these first oceans spreading across the planet, let the idea of vast, still waters settle into your thoughts. Let the image of a world gently wrapped in dark seas slow your breathing, soften your awareness, and guide you toward deeper calm, where everything moves gradually and nothing demands attention. The oceans have arrived, not suddenly, but through patience, gravity, and time. And with them, Earth takes one more quiet step toward becoming a living world. As the first true oceans settled across Earth's surface, the planet itself began to behave differently, because liquid water introduced a slow, regulating rhythm that solid rock and vapor alone could never provide, allowing heat to move more gently between the interior, the surface, and the sky. The oceans did not rush to reshape the world. Instead, they worked quietly, absorbing excess warmth during brighter periods and releasing it gradually during darker ones, creating a planetary breathing that softened extremes and encouraged long-term stability. The surface of Earth, once dominated by glowing rock and violent temperature shifts, now experienced a gentler exchange of energy. Sunlight reached the ocean's surface through a thinning atmosphere and was absorbed into the water, where it spread downward and outward, distributing warmth across wide regions instead of concentrating it in one place. This spreading of heat allowed the crust beneath the oceans to cool more evenly, reducing stress and helping the young planet settle into a calmer structural state. Beneath the surface, the interaction between water and rock continued without pause. Seawater seeped into cracks in the crust, carrying heat away from deeper layers and dissolving minerals along the way. This slow circulation created chemical gradients within the oceans, enriching them with dissolved elements that drifted gently through the water. Iron, magnesium, calcium, and countless trace minerals spread throughout the seas, creating a complex chemical environment shaped by patience rather than force. At the same time, the oceans began to influence the atmosphere in profound ways. Carbon dioxide, once abundant in the sky, dissolved into the water and reacted with minerals on the seafloor, forming stable compounds that removed this gas from the atmosphere. As carbon dioxide levels slowly decreased, the planet cooled further, allowing even more water vapor to condense and fall as rain. This quiet feedback loop reinforced the ocean's presence, strengthening their role as Earth's primary stabilizer. The atmosphere itself became lighter and more transparent as water left the sky and settled on the surface. Clouds remained, but they no longer dominated every moment. Light filtered through with greater clarity. though still softly, casting muted reflections across the ocean's surface. The planet's rotation carried these illuminated regions slowly beneath the sun, introducing the earliest sense of day and night cycles shaped by water's calming influence. Imagine the view from high above Earth during this age, where vast, dark oceans wrap around the planet like a living skin, responding subtly to the warmth of the sun and the cooling of space. There are no continents yet, as we would recognize them, only scattered regions of higher crust rising briefly above the water before sinking again under geological forces. The dominant feature is water, continuous and patient, holding the planet in a quiet embrace. Within this watery world, motion remains gentle. Currents form slowly as temperature differences develop between regions warmed by sunlight and regions resting under dimmer skies. These currents move heat across the planet in long, smooth paths, preventing stagnation and helping the oceans remain active without becoming turbulent. The seas begin to act not as still pools, but as a connected system, quietly circulating energy and matter. As you imagine this breathing planet, let the idea of slow, steady exchange guide your own breathing. Let warmth move gently through your awareness, and then fade softly, replaced by cooler calm. Feel the planet settling into balance, and allow that balance to settle into you as well, bringing a sense of deep rest shaped by water, time, and quiet transformation. Earth has begun to breathe through its oceans, and with each slow cycle, it moves further away from chaos and closer to the calm conditions that will one day allow life to rise from the sea. As the oceans deepened and spread across nearly the entire surface of the young Earth, they did not remain motionless. Because even in a world without familiar winds or continents, water responds gently to differences in temperature, gravity, and the slow rotation of the planet itself, creating the earliest forms of oceanic movement. These first currents were not driven by storms or tides as we know them today, but by subtle contrasts between warm regions under sunlight and cooler regions resting beneath thicker cloud and shadow. The sun still filtered through a soft and hazy atmosphere, warmed some portions of the ocean more than others, and this uneven heating caused the water to expand slightly in warmer areas while cooler water remained denser and heavier. Over long stretches of time, this difference was enough to set the oceans into motion, as warm water drifted slowly across the surface and cooler water sank gently below, forming vast, slow circulation patterns that moved without urgency. Imagine these currents not as rushing streams, but as enormous, quiet rivers within the sea, moving so slowly that their motion would be invisible to the eye, yet powerful enough to redistribute heat across the planet. Water that warmed under the sun's dim light traveled outward and gradually cooled, while colder water from deeper layers rose elsewhere to take its place, creating a continuous and calming exchange that helped Earth maintain balance. Because there were no large continents yet to block or redirect these movements, the currents could travel freely around the globe, wrapping the planet in a connected system of circulating water. Heat absorbed near the equator-like regions drifted toward cooler latitudes, while cooler water returned inward, smoothing temperature differences and preventing extreme conditions from developing anywhere for long. Beneath the surface, the interaction between seawater and the rocky crust continued to influence these movements. Heat rising from the planet's interior warmed the deepest waters, causing them to lift slowly upward, while cooler surface waters sank gently in other regions. This vertical circulation added another layer to the ocean's quiet motion, linking the deep sea floor with the surface in a slow and steady exchange. The absence of strong winds meant the ocean surface remained largely smooth, with only subtle ripples forming where temperature gradients met or where geothermal heat disturbed the water from below. The seas appeared dark and glassy, reflecting the muted light of the sky in broad, indistinct patterns. This calm surface allowed heat to move efficiently between ocean and atmosphere, strengthening the stabilizing effect water had on the planet's climate. As these ancient currents moved, they carried dissolved minerals throughout the oceans, spreading chemical ingredients evenly across the planet. This distribution prevented stagnation and ensured that no region became isolated or depleted, laying the groundwork for a chemically rich and balanced marine environment. The oceans were no longer just reservoirs of water, but dynamic systems quietly shaping Earth's future. Imagine drifting within these early seas, suspended in warm, mineral-rich water that moves almost imperceptibly around you, guided by forces too gentle to notice yet too persistent to stop. There is no sound, no turbulence, only the sensation of slow motion and deep time, as if the entire ocean were breathing in harmony with the planet itself. As you hold this image, let your thoughts follow the same pattern, moving slowly and evenly, without sudden shifts or distractions. Feel warmth spreading gently through your awareness, then sinking into deeper calm, just as surface waters drift and descend in the ancient sea. Let the quiet movement of these first currents guide you toward rest, where motion exists without effort and change unfolds without urgency. The oceans have learned to move, not with force, but with patience. And in this movement, they continue to shape a planet that is gradually becoming calm enough to hold life within its depths. As the ancient oceans continued their slow and patient circulation across the surface of the young Earth, they began a quiet conversation with the planet's solid crust, because water is never passive when it rests against stone, and over long periods of time, even the hardest rock responds to its presence. This interaction did not happen through sudden razrushma or dramatic collapse, but through subtle chemical exchanges and gentle erosion that unfolded almost invisibly, shaping the surface layer by layer. The seawater, rich with dissolved minerals and warmed by both sunlight above and geothermal heat below, seeped into cracks and fractures in the cooling crust, carrying energy downward and bringing new elements back into the ocean. As this water moved through the rock, it altered the minerals it touched, slowly transforming them and releasing additional substances into the sea. These processes softened the rigid boundary between land and water, creating a planet where stone and ocean influenced one another continuously. Over immense spans of time, this steady interaction began to differentiate Earth's surface. Some regions of the crust grew denser and sank slightly beneath the weight of the oceans, while other regions composed of lighter material began to rise gradually. These subtle differences marked the earliest steps toward the separation between ocean basins and emerging continental regions, even though the planet was still largely covered by water. The oceans themselves became deeper and more chemically complex as water rock reactions continued. Minerals such as silica and iron spread throughout the seas, giving the water new properties and increasing its ability to store and transport heat. This made the oceans even more effective at regulating the planet's temperature, strengthening their role as a stabilizing force during Earth's long cooling process. Beneath the surface, hydrothermal systems emerged where seawater met hot rock along fractures in the crust. Water circulated downward, heated by the planet's interior, and then rose back into the ocean carrying dissolved minerals and energy. These gentle plumes did not disturb the calm surface above, yet they quietly enriched the deep ocean, creating gradients of temperature and chemistry that added depth and structure to the marine environment. Imagine the ocean floor during this era, dark and vast, illuminated only by faint glows where warm water rises from the crust. The surrounding water moves slowly, carrying minerals away and replacing them with cooler currents from above. There is no sense of urgency in this movement, only the calm persistence of processes that unfold over geological time. Above, the ocean surface remains smooth and reflective, absorbing light and releasing heat in steady balance. The atmosphere above it continues to thin as more gases dissolve into the water and become locked into rock through chemical reactions. The sky grows slightly clearer, and the planet's overall energy becomes more evenly distributed, further calming Earth's early environment. As you imagine water meeting stone in this quiet exchange, allow the idea of slow transformation to settle into your thoughts. Feel how gentle contact, repeated endlessly, can reshape even the most solid forms. Let this image guide you toward deeper calm, where change happens without force and time moves without pressure. The oceans are no longer just forming. They are now shaping the planet itself, guiding Earth toward the balanced state that will one day allow life to emerge from water and touch the air above. As the oceans continued to rest upon Earth's surface with immense weight and patience, the crust beneath them responded in slow and subtle ways. Because water does not merely sit upon a planet, it presses, cools, and reshapes it over vast spans of time, guiding the gradual differentiation between deep ocean basins and lighter regions that would one day become continents. This transformation did not happen through sudden uplift or dramatic separation, but through a long conversation between heat, pressure, and buoyancy unfolding quietly beneath the water. The crust beneath the oceans cooled faster than the crust exposed to air, becoming denser and heavier as heat escaped into the surrounding water. In contrast, regions composed of lighter materials retained warmth slightly longer and resisted sinking, beginning a slow upward drift relative to the surrounding seafloor. Over immense stretches of geological time, this difference caused some portions of the crust to rise gently, while others settled deeper, establishing the earliest outlines of continental platforms hidden beneath the ancient seas. These rising regions were not dry land yet. They existed as broad, submerged plateaux beneath kilometers of water, their presence marked only by subtle changes in depth and temperature. Ocean currents flowed over them smoothly, unaware of the long future they represented. Yet these submerged highlands played a crucial role by redirecting slow-moving currents, shaping patterns of heat distribution and chemical circulation throughout the global ocean. As heat continued to escape from Earth's interior, the mantle beneath the crust remained active, flowing slowly like thick, luminous wax under pressure. This movement drove the gradual shifting of large crustal sections, allowing ocean basins to deepen while continental roots grew thicker and more buoyant. The oceans responded calmly to these changes, filling every new depression without resistance and flowing away from every rising region with quiet grace. Beneath the water, the seafloor became increasingly varied. Long ridges formed where molten rock rose and cooled. Gentle slopes developed where crust stretched and thinned. These features shaped the paths of deep currents, guiding mineral-rich water across the planet in slow, looping journeys that connected distant regions of the ocean into a single, breathing system. Above, the ocean's surface remained largely unchanged, smooth and dark under a sky that was still muted but slowly growing clearer. The sun's light reached the water more consistently now, penetrating deeper and warming the upper layers, while the depths remained cool and stable. This vertical contrast strengthened circulation and further balanced the planet's climate, reinforcing the oceans as Earth's primary stabilizing force. Imagine drifting slowly above this ancient world, knowing that beneath the calm surface, enormous changes are unfolding at a pace too slow to feel. Vast regions of crust are rising by tiny amounts. Others are sinking just as gently. The oceans accept all of it without disturbance, maintaining their quiet presence while shaping the future geography of the planet. As you hold this image, allow the idea of hidden transformation to settle into your thoughts, reminding you that not all change needs to be visible or immediate to be meaningful. Let your breathing slow as you imagine continents forming silently beneath endless water, guided by gravity, heat, and time rather than force. The oceans are now shaping not only climate and chemistry, but also the very structure of the planet, preparing the stage for shores, coastlines, and the future meeting of land and sea that will one day define Earth's living surface. As the oceans deepened and spread with quiet confidence across the planet, their influence extended upward into the sky. Because water does not only shape stone beneath it, it also transforms the air above it, slowly and persistently, until an atmosphere once heavy and suffocating begins to soften, thin, and breathe more freely. This transformation unfolded without drama, guided by chemistry, temperature, and the steady presence of liquid water resting on the surface. In the earliest ages, Earth's atmosphere was thick with gases released from volcanoes, especially carbon dioxide and water vapor, creating a dense blanket that trapped heat close to the surface. When oceans formed, they became vast reservoirs capable of absorbing these gases, drawing them down from the sky and dissolving them into the water below. Carbon dioxide, in particular, reacted with seawater and minerals on the ocean floor, becoming locked into solid compounds that settled quietly into the crust, reducing the atmosphere's heaviness over immense spans of time. As more gas moved from sky to sea, the atmosphere gradually lost its oppressive weight, allowing heat to escape more efficiently into space and helping the planet cool further. With cooling came clarity. The thick veil of steam thinned, clouds became less continuous, and sunlight reached the ocean's surface with greater consistency, though still softened by haze. The planet began to experience a gentler contrast between light and shadow, laying the groundwork for stable cycles of warmth and rest. Imagine standing above this ancient world as the sky slowly changes its character, shifting from a dark, heavy canopy into something lighter and more spacious, where light can drift downward in calm layers instead of being trapped above. The horizon becomes more defined. The division between sea and sky grows clearer. Earth begins to feel less like a closed vessel of heat and more like an open system in quiet exchange with space. The oceans also played a role in stabilizing water itself within the atmosphere. As liquid water covered more of the surface, evaporation and condensation entered a balanced rhythm, allowing clouds to form, drift, and dissolve without overwhelming the planet. Rain continued, but no longer endlessly. It became part of a cycle, falling, flowing, evaporating, and returning again with gentle regularity. With this balance, the atmosphere began to organize itself into layers defined by temperature and density. Warm air rose slowly from the ocean's surface. Cooler air settled above it. Subtle movements developed, setting the earliest patterns of circulation that would one day grow into winds shaped by continents and mountains. For now, these movements remained soft and broad, guiding heat and moisture without turbulence. As the sky cleared, the sun's light reached deeper into the oceans, warming the upper layers and strengthening the quiet currents that moved heat around the planet. This interaction between light, water, and air further stabilized Earth's climate, creating an environment that changed slowly rather than violently, an environment capable of sustaining long processes without collapse. Imagine the feeling of this early sky, lighter than before, still dim but no longer oppressive, stretching calmly above a dark, global ocean that reflects its soft glow. The planet feels balanced now, as if it has found a comfortable state after long ages of tension. Nothing presses too hard. Nothing escapes too quickly. As you imagine this calmer atmosphere forming above the oceans, allow the sense of openness to settle into your own awareness. Feel space expanding gently around your thoughts. Feel heaviness lifting without effort. Let the quiet clearing of Earth's sky guide you toward deeper calm, where breath moves freely and the mind rests without pressure. The oceans have not only covered the planet, they have taught the sky how to breathe, shaping an atmosphere that will one day support clouds, winds, and life beneath a gentler sun. As the oceans and atmosphere settled into a calmer balance, Earth entered a long period of relative stability, A quiet age in which dramatic changes became rare and slow processes were finally allowed to unfold without interruption, because the presence of vast connected oceans acted like a gentle anchor, holding the planet in a steady state while time itself seemed to stretch and soften. This was not a moment of stillness without motion, but a phase where change occurred so gradually that it felt almost timeless. During this age, the oceans continued to absorb and release heat with remarkable patience, smoothing out the contrast between regions warmed by sunlight and regions resting under dimmer skies. Day-night cycles became more predictable as the atmosphere thinned and organized itself, allowing heat to flow in slow, repeating patterns rather than chaotic surges. The planet began to experience a rhythm, a quiet alternation between warmth and cooling that repeated again and again without disruption. Beneath the surface, the oceans remained deeply connected to the planet's interior. Heat rising from below continued to warm the deepest waters, while cooler surface waters slowly sank in distant regions, maintaining the vast circulation that kept the seas active without turbulence. These movements carried minerals across the globe, ensuring that no part of the ocean became isolated or stagnant, and that chemical ingredients remained evenly distributed through the water. The surface of the ocean reflected the sky above it in broad, dark expanses, absorbing sunlight during brighter periods and releasing it gently as the planet turned away from the sun. This exchange prevented rapid cooling at night and excessive heating during the day, reinforcing the sense of balance that now defined Earth's environment. The oceans were no longer forming or expanding significantly. They were maintaining, regulating, and preserving. Above the water, clouds formed and dissolved in slow cycles, drifting across the planet without urgency. Rain fell in measured intervals, replenishing surface waters and returning minerals to the sea through gentle runoff from emerging highlands. The water cycle had become self-sustaining, repeating itself quietly and reliably, guided by the presence of the oceans below. Imagine this world from a distant, drifting perspective, where Earth appears as a dark sphere wrapped in calm water, slowly turning beneath a softened sun. There are no sharp contrasts, no sudden storms, no dramatic shifts in color or light. Everything feels muted, balanced, and deeply settled, as if the planet has found a comfortable posture within the vastness of space. This long night of stability created the conditions necessary for complex processes to begin. Chemical reactions in the oceans could proceed without being erased by extreme conditions. Temperature gradients remained gentle enough to persist. Energy flowed steadily rather than violently. The seas became a quiet laboratory, holding molecules together long enough for new arrangements to emerge. As you imagine this extended calm, let the idea of time stretching gently guide your thoughts. Feel moments becoming longer and softer, unhurried and unforced. Let the sense of a planet resting in balance settle into your breathing, slowing it naturally and without effort. The oceans now serve as Earth's memory, holding warmth, chemistry, and motion in quiet continuity. They preserve conditions not for moments, but for ages, allowing the planet to remain calm long enough for the next great transformation to approach, one that will rise not from fire or stone, but from the water itself. As Earth rested within this long age of balance, the oceans became more than regulators of temperature and atmosphere, because within their calm depths, a quiet chemistry began to unfold, guided by time, gentle energy flows, and the steady presence of liquid water that allowed molecules to meet, separate, and meet again without being torn apart. This was not the chemistry of sudden reactions or violent change, but a slow exploration of possibility, carried out patiently within the shelter of the seas. The water itself played an essential role, because liquid water is uniquely suited to hold substances in suspension, allowing minerals, gases, and organic compounds to drift together, interact, and remain stable long enough for complex structures to form. In the ancient oceans, dissolved carbon dioxide, nitrogen compounds and minerals released from the crust mixed freely, creating a rich chemical environment that changed subtly from place to place, shaped by temperature gradients and gentle circulation. Near the surface, sunlight filtered through the clearer atmosphere and penetrated the upper layers of the sea, providing energy that drove simple chemical reactions without overwhelming them. Deeper down near the ocean floor, heat rising from within the planet created warm pockets where different reactions could occur, sheltered from direct radiation and buffered by surrounding water. Between these regions, slow currents transported molecules across vast distances, ensuring that chemistry was never isolated to a single location. Along the seafloor, especially near hydrothermal regions where warm, mineral-rich water emerged from the crust, unique chemical conditions developed. These areas were not violent eruptions, but steady releases of warmth and dissolved elements that spread gradually into the surrounding sea. The contrast between warm vent water and cooler ocean water created gentle gradients that encouraged molecules to organize themselves, forming structures that could persist rather than disperse immediately. Imagine these ancient seas as immense, dark laboratories, where every movement is slow and every interaction unfolds over long spans of time. Molecules drift together, bind briefly, separate, and bind again in new ways, exploring countless arrangements guided only by physical laws and the availability of energy. There is no intention, no urgency, only the quiet persistence of chemistry allowed to continue without interruption. The oceans protected these processes by maintaining stable temperatures and shielding delicate reactions from harsh conditions above. Storms did not scour the depths. Radiation did not penetrate far. The water acted as a buffer, absorbing disturbances and preserving calm within its interior. This stability allowed increasingly complex chemical networks to emerge, networks capable of sustaining themselves and interacting with their environment in subtle ways. As the atmosphere continued to evolve above, the oceans quietly accumulated the products of these reactions, storing them, redistributing them, and allowing them to interact further. Over immense spans of time, this gentle chemistry laid the groundwork for life, though life itself had not yet fully appeared. The seas were preparing, patiently and without awareness, for a transformation that would eventually change the planet forever. As you imagine these silent processes unfolding beneath the ocean surface, allow your thoughts to slow to the same pace. Feel ideas drifting gently, meeting and reshaping without pressure. Let the sense of quiet experimentation guide you toward deeper calm, where nothing needs to resolve quickly and every moment has space to unfold. The oceans now hold more than water. They hold possibility. Suspended in quiet balance, waiting for the right conditions to allow something new to rise from their depths. As the oceans continued to hold Earth in their wide and patient embrace, subtle boundaries began to emerge between water and rising crust. Not yet as familiar coastlines with sand and cliffs, but as slow transitions where ocean depths shallowed, and the planet's surface hinted at future separation. These early boundaries were soft and temporary, shaped by gentle uplift, cooling rock, and the steady pressure of water resting above them, creating places where ocean and stone met in long, quiet contact. In these shallow regions, the interaction between water and rock intensified, because sunlight could now reach the seafloor more easily and temperature differences became slightly more pronounced. Warm surface water drifted slowly over cooling stone, while deeper, cooler water lingered nearby, creating mild gradients that encouraged movement without turbulence. Minerals dissolved from the rock more readily here, enriching the water with new chemical ingredients and creating zones of increased complexity. Imagine these early shallows as vast, submerged plains gently sloping upward beneath dim light, where water moves slowly and evenly, guided by gravity rather than wind. There are no breaking waves, no crashing sounds, only the quiet presence of water resting against stone for long periods of time. The surface above remains calm, reflecting a sky that is still muted but increasingly open, allowing soft light to filter downward in long, gentle paths. These regions become important places within the ocean system because they allow different environments to exist close together without sharp division. Shallow water warms more easily during the planet's slow rotation under the sun, while deeper water remains cooler and more stable. This contrast encourages slow circulation, drawing nutrients and dissolved elements upward and spreading them across the shallows, where chemistry becomes more active and diverse. As Earth's crust continues its gradual differentiation, some of these shallow areas remain submerged, while others rise slightly higher, approaching the surface without fully breaking through. Water responds calmly, flowing away from rising regions and filling nearby depressions, maintaining balance while allowing the surface to change beneath it. Over long spans of time, these gentle adjustments set the stage for the eventual appearance of dry land, though the oceans still dominate nearly the entire planet. The atmosphere above responds to these changes as well, because shallow waters interact differently with air than deep oceans do. Evaporation becomes slightly more efficient in these regions, contributing moisture to the sky and reinforcing the global water cycle. Clouds form, drift, and dissolve with quiet regularity, continuing the exchange between sea and sky that defines Earth's calm climate. Imagine drifting slowly above one of these ancient boundary zones, aware that beneath the smooth surface subtle transformations are underway. The water is warm, but not hot, dark, but not opaque, moving with a steadiness that feels almost meditative. The rock below cools and hardens, while the water above carries away heat and minerals, guiding the planet toward greater structural clarity. As you hold this image, allow the idea of gentle boundaries to settle into your thoughts, reminding you that separation does not always require force or sharp edges. Sometimes change emerges through long contact and quiet adjustment, shaped by patience rather than disruption. Let this sense of gradual transition guide you into deeper calm, where thoughts drift gently from one state to another without resistance. The oceans are now beginning to outline the planet's future surface, not by retreating, but by interacting, shaping, and responding to the slow rise of stone beneath their calm depths. As Earth continued to rest within the steady presence of its global oceans, something subtle yet profound began to take shape. Because water does not merely move and regulate, it also remembers, holding within its depths a long archive of temperature, chemistry, and planetary change that unfolds over immense spans of time. The oceans became a living memory for the planet, recording slow shifts in climate, crustal movement, and atmospheric composition without ever needing to mark them visibly on the surface. Every layer of water carried a slightly different story. Near the surface, warmth from the sun entered gently and spread outward, while deeper layers remained cooler and more stable, preserving conditions that changed only gradually. These layers did not mix chaotically. Instead, they interacted through slow diffusion and circulation, allowing information about temperature and chemistry to pass between them over long periods. In this way, the oceans stored Earth's past within their structure, maintaining continuity even as the planet evolved. As minerals continued dissolving from the crust and spreading through the seas, their concentrations changed slowly, reflecting the balance between volcanic input, chemical reactions, and sedimentation on the seafloor. These changes did not erase what came before. They layered new conditions atop old ones, creating a gradual record of Earth's internal activity and surface cooling. The oceans became a place where nothing was truly lost, only transformed and redistributed. Beneath the surface, sediments began to accumulate on the ocean floor, settling quietly as tiny particles sank from the water above. These sediments carried with them the chemical signature of the ocean at the time they formed, preserving information about temperature, mineral content, and atmospheric interactions. Over vast spans of time, layer upon layer settled, creating a slow and continuous archive written not in ink, but in stone and mineral grains. Imagine the deep ocean as a vast library without walls, where each slow movement of water adds a new page to a story that is never rushed and never erased. Currents carry information from one region to another. Heat is stored, released, and stored again. Chemistry evolves gently, guided by stability rather than disruption. Everything unfolds at a pace that feels timeless. This memory function of the oceans played a critical role in Earth's long-term stability because it prevented abrupt changes from dominating the planet's behavior. Sudden inputs of heat or gas were absorbed, diluted, and spread out over long periods, smoothing transitions and allowing the planet to adapt gradually. The oceans acted as a buffer not only in space, but in time, slowing change and preserving continuity. Above the water, the atmosphere responded to this stability by becoming increasingly organized, settling into predictable patterns of circulation and moisture exchange. The sun's light continued to drive gentle cycles of evaporation and condensation, while the oceans ensured that these cycles remained balanced and repeatable. Earth began to feel reliable, not because it was static, but because its changes were slow and integrated. As you imagine these deep, memory-holding waters, allow your own thoughts to adopt a similar quality, where experiences are not rushed or erased, but stored calmly and integrated over time. Feel the sense of continuity settling into your awareness, bringing with it a quiet reassurance that change does not need to be sudden to be meaningful. The oceans have become Earth's long-term memory, holding warmth, chemistry, and history within their depths, guiding the planet gently forward through time and preparing the conditions for the final transformation that will soon emerge from the water itself. As the oceans deepened into their role as Earth's quiet memory, they also began to develop the earliest rhythms of movement, not yet shaped by the familiar pull of a nearby moon or the strong winds of a mature atmosphere, but guided instead by the planet's rotation, subtle gravitational interactions, and gentle differences across the globe. These first rhythms were faint and slow, yet they introduced repetition and timing into the behavior of water, allowing the oceans to move not only through space, but through cycles. Earth's rotation caused water to respond gradually, creating broad, slow shifts in sea level that traveled around the planet like deep breaths taken by the ocean itself. These movements were not dramatic rises and falls, but slight oscillations that gently redistributed water from one region to another over long periods. The absence of sharp coastlines meant these motions spread smoothly, without crashing or turbulence, maintaining the calm surface that defined this early world. Gravitational influences from the sun also played a subtle role, stretching the ocean slightly along the line between Earth and its star. This effect was gentle and widespread, producing slow variations in ocean depth that passed almost unnoticed, yet they added another layer of rhythm to the planet's waters. The oceans began to experience a soft, repeating pattern, a quiet pulse that mirrored the larger motions of Earth within the solar system. These early rhythmic movements helped prevent stagnation, encouraging the slow mixing of water layers and the redistribution of heat and dissolved materials. Even the faintest motion allowed the oceans to remain active and responsive, ensuring that energy and chemistry continued to circulate rather than settle into stillness. This motion was calm, continuous, and deeply stabilizing. Imagine drifting within these ancient seas, where the water moves almost imperceptibly around you, guided by forces too subtle to feel directly. yet strong enough to shape the entire planet over time. There is no sound to mark these movements, no visible waves to signal change, only a quiet sense of motion that unfolds slowly, like the turning of the sky itself. As these rhythms repeated, they introduced regularity into the planet's environment, helping chemistry and temperature adjust in predictable ways. Patterns formed, not sharply defined, but gently reinforced through repetition. The oceans learned how to move in cycles, and in doing so, they prepared the stage for more complex interactions between water, land, air, and eventually life. Above the surface, the atmosphere responded to these slow oceanic rhythms, adjusting patterns of evaporation and condensation in subtle harmony with the water below. Moisture rose and fell in step with the ocean's quiet pulse, strengthening the water cycle and reinforcing Earth's growing stability. As you imagine these first rhythms unfolding across a dark, endless ocean, allow the idea of gentle repetition to settle into your mind. Feel the comfort of patterns that return without force, movements that repeat without demand. Let your breathing align with this slow, steady pulse, guiding you toward deeper calm where motion exists without disturbance. The oceans are no longer just present. They are now rhythmic, breathing softly in time with the planet's rotation and its place beneath the sun, shaping Earth through cycles that feel eternal in their calm simplicity. As Earth's oceans continued their long residence upon the planet's surface, they slowly developed the qualities that would define them for all future ages. Because water that remains in contact with rock and air for immense spans of time does not stay pure or unchanged, but instead gathers memory, weight, and character through countless quiet interactions. One of the most important of these changes was the gradual rise of salinity, a transformation that unfolded so slowly it felt almost timeless. Rainwater falling from the sky was initially fresh, carrying very few dissolved substances as it returned to the surface. Yet, as this water flowed gently across exposed rock and through shallow submerged regions, it dissolved small amounts of minerals, carrying them back into the oceans. Sodium, chloride, magnesium, calcium, and countless other ions entered the sea in tiny quantities, drop by drop, cycle after cycle. Nothing dramatic occurred in a single moment, but over vast spans of time, these contributions accumulated, giving the oceans their distinctive salty nature. Once dissolved, these minerals did not easily leave the water. Evaporation removed pure water and returned it to the sky, but the dissolved salts remained behind, slowly increasing in concentration as the cycles repeated. The oceans grew denser and heavier, and with that density came new depth, both physical and chemical. The water began to behave differently, sinking and rising in response to subtle variations in temperature and salinity, creating layered structures that added complexity to ocean circulation. Imagine these layers forming gradually within the ancient seas, where warmer, lighter water drifted gently above cooler, saltier depths, and where boundaries between layers remained soft and flexible, rather than sharp. These layers allowed the oceans to store heat efficiently, releasing it slowly over time and reinforcing Earth's growing climate stability. The seas became not only wide, but deep in their ability to regulate the planet. At the same time, sediments continued to settle onto the ocean floor, locking away minerals and chemical signatures in thin layers that accumulated patiently. These sediments altered the shape of the seafloor, smoothing some regions while building others upward in slow increments. The ocean basins deepened and matured, their contours shaped by the constant presence of water pressing downward with quiet persistence. The increasing depth of the oceans changed how light moved through them. Sunlight penetrated the upper layers, fading gradually as it traveled downward, creating zones of brightness and dimness that felt calm and ordered. Near the surface, light scattered softly, while deeper regions remained in permanent twilight, wrapped in darkness that was not empty, but protective and still. Imagine drifting downward through these layers, where the brightness above softens and fades, replaced by dim light and gentle waves of pressure that feel steady rather than overwhelming. Motion becomes slower. Sound disappears. Time in itself seems to stretch, allowing thoughts to drift without urgency. These conditions further supported the quiet chemistry unfolding within the oceans, allowing reactions to proceed at measured rates and giving complex structures the chance to persist. The character of the ocean was no longer defined only by its presence, but by its internal order, its salinity, its depth, and its layered calm. As you imagine these deepening seas, allow your thoughts to sink gently as well, moving from surface concerns into deeper calm. Feel the weight of the day fade as your awareness settles, like particles drifting downward through still water. Let the ocean's slow acquisition of character guide you toward rest, reminding you that identity and balance can emerge gradually, without effort or strain. The oceans have now found their depth and their voice, shaped by salt, stone, and time, preparing the planet quietly for the final steps toward a living world. As Earth's oceans settled into their deep, layered character, the planet entered a long and quiet interval that felt almost like a held breath, because the major forces that once reshaped the surface rapidly had softened, leaving behind a world where change continued, but at a pace slow enough to feel restful rather than urgent. The oceans now covered most of the planet, dark and vast, absorbing light, storing heat, and gently moderating every interaction between sky and stone. During this time, Earth appeared calm from afar, rotating steadily beneath the sun with no dramatic flashes or violent upheavals. The surface of the oceans reflected muted light during the day and released stored warmth into the night, preventing sudden drops in temperature and allowing the planet to maintain a stable range of conditions. This constancy created a sense of quiet endurance, as if the planet itself had learned how to rest. Beneath the surface, movement continued, but always gently. Slow currents carried heat and minerals across great distances, linking distant regions of the ocean into a single unified system. Warmer waters rose gradually in some areas, while cooler, saltier waters descended in others, maintaining circulation without turbulence. The deep ocean became a place of profound stillness, where motion existed only as a soft, continuous drift. The seafloor remained active in subtle ways, releasing heat through fractures and ridges, yet this activity no longer dominated the planet's behavior. Instead, the oceans absorbed and distributed this energy quietly, preventing it from creating extremes at the surface. Minerals continued to dissolve and spread, enriching the water further and reinforcing the complex chemistry that had been building patiently for ages. Above the water, the atmosphere now felt lighter and more open, allowing sunlight to reach the surface with gentle consistency. Clouds formed and moved in calm patterns, no longer overwhelming the sky. Rain fell as part of a balanced cycle, nourishing the oceans without flooding the planet. The exchange between sea and sky had become reliable and soothing, repeating itself with quiet regularity. Imagine floating above this world at this moment, seeing an endless ocean stretching in every direction beneath a softly glowing sky. There are no sharp boundaries, no loud signals of change, only the steady rotation of the planet and the slow movement of water responding to light and gravity. The horizon feels distant and smooth, blending sea and sky into a single tranquil scene. This long calm period was essential because it allowed delicate processes to continue without interruption. Chemical reactions in the water could proceed steadily. Temperature gradients could persist long enough to matter. Structures formed by chance could remain intact instead of being destroyed by sudden extremes. The oceans provided shelter not only from physical forces, but from rapid change itself. As you imagine this resting planet, let the idea of prolonged calm settle into your thoughts. Feel what it is like to exist in a space where nothing demands immediate response, where time stretches and softens, and where stability itself becomes a form of protection. Allow your breathing to slow naturally, guided by the image of a world held gently by water. The oceans now cradle Earth in a quiet pause, holding conditions steady and allowing the next transformation to approach gradually. Life has not yet fully emerged, but the planet is ready, resting in the calm embrace of its seas, waiting without urgency for the moment when something new will rise from the depths. As Earth remained wrapped in the deep stillness of its global oceans, the water itself began to guide the planet toward its next transformation, not by force or intention, but by offering an environment where complexity could remain intact long enough to learn how to persist. The oceans became a quiet teacher, shaping chemistry through patience, repetition, and gentle constraint, allowing matter to organize itself without being torn apart by extremes. Within these calm waters, molecules were no longer scattered randomly or destroyed as quickly as they formed. Instead, they drifted slowly, meeting again and again under similar conditions, guided by temperature gradients, mineral surfaces, and the subtle motion of currents. Water softened every interaction, absorbing excess energy and releasing it gradually, preventing reactions from becoming too violent and allowing fragile structures to survive. Along the ocean floor, especially near regions where warm mineral-rich water seeps steadily from the crust, chemistry took on a slightly different character. These areas provided a gentle contrast between warmth and coolness, between dissolved minerals and surrounding seawater. Molecules that passed through these regions encountered repeated opportunities to assemble, disassemble, and reassemble, exploring countless configurations over immense spans of time. Nothing rushed them. Nothing erased their progress abruptly. Imagine these environments as quiet classrooms beneath the sea, where water moves slowly and conditions remain stable for ages. Mineral surfaces act like gentle guides, holding molecules in place just long enough for bonds to form. Heat flows softly through the system, offering energy without chaos. Currents carry newly formed structures away, spreading them into wider regions where they can persist or change further. Near the surface, filtered sunlight added another layer of influence, providing mild energy that drove reactions without overwhelming them. Light entered the water gradually, fading with depth, creating zones where different processes could unfold side by side. Some molecules formed near the surface under dim light. Others assembled in deeper, darker regions where heat from below replaced sunlight as the driving force. Together, these zones created a rich and varied chemical landscape, all contained within the protective calm of the oceans. Over time, certain arrangements proved more stable than others. They lasted longer. They interacted more effectively with their surroundings. They became more likely to persist when carried by currents or exposed to changing conditions. This was not selection in the biological sense yet, but a quiet sorting where stability itself became a guiding principle. The ocean rewarded structures that could endure its gentle rhythms. Above, the surface of the sea remained calm, reflecting a softened sky and absorbing sunlight in steady measure. Day and night continued their slow alternation, reinforcing cycles that chemistry could adapt to. The planet felt deeply settled, as if it were listening rather than acting, allowing internal processes to find their own paths without interference. As you imagine this phase of Earth's history, let the idea of gentle guidance settle into your thoughts. Consider how learning does not always require instruction or urgency, but can arise from repetition and calm presence. Let your mind drift like molecules in warm water, encountering ideas softly, releasing them, and encountering them again without effort. The oceans have become more than a setting. They have become a quiet influence, shaping the path forward through steadiness and restraint. In their depths, chemistry is learning how to last, how to adapt, and how to move gently toward something new, while the planet remains wrapped in a calm that feels almost timeless. As the oceans continued to offer their steady protection, something subtle and extraordinary began to occur within their depths, because the quiet chemistry that had been unfolding for so long reached a point where certain patterns no longer dissolved back into simplicity, but instead persisted, repeating themselves gently within the shelter of warm water. These were not yet living beings in the way we understand life today, but they were organized systems, fragile yet enduring, held together by the calm conditions the oceans had patiently maintained. Within these ancient seas, clusters of molecules began forming enclosed structures, softly separated from the surrounding water by delicate boundaries. These boundaries allowed an inside and an outside to exist for the first time, creating small regions where chemistry could proceed with greater focus and continuity. Water supported these structures by stabilizing their shapes, absorbing excess energy, and allowing reactions inside them to unfold without disruption. Imagine these early structures drifting slowly through the ocean, carried by gentle currents, illuminated faintly by light filtering from above or warmed by heat rising from below. They do not struggle. They do not compete. They simply exist, maintaining their form long enough to interact with their surroundings in meaningful ways. Some grow slightly more stable, others fade and dissolve. The ocean accepts all outcomes without judgment, offering endless opportunities for formation and persistence. Over long spans of time, certain chemical networks become more effective at sustaining themselves. They draw in energy from their environment and use it to maintain their structure. They interact with surrounding molecules in ways that allow them to continue existing rather than falling apart. This quiet persistence marks a profound turning point because it introduces continuity into the chemistry of the planet. The oceans play a central role in this transition by maintaining a stable temperature range and protecting these delicate systems from extremes. Without water's ability to buffer heat and dilute disturbances, such fragile patterns would vanish as quickly as they formed. Instead, the seas provide a calm space where repetition is possible, where structures can be tested gently rather than destroyed abruptly. Above the surface, the sun continues its steady rhythm, rising and setting with quiet reliability. Its light penetrates the upper layers of the sea, offering energy in soft measure, while deeper waters remain dark and constant, shaped by geothermal warmth. This layered environment allows different forms of organization to emerge side by side, each adapted to its own niche within the ocean's depth. Imagine the planet during this time, still dominated by water, still quiet and dark, yet now carrying within its seas countless tiny centers of organization drifting slowly through the depths. There is no visible sign of life from afar, no dramatic change in the planet's appearance, yet internally, something irreversible has begun. The oceans are no longer only shaping climate and chemistry. They are quietly holding the earliest expressions of life itself. As you imagine this moment, let the idea of gentle beginnings settle into your awareness. Consider how something profound can arise without noise or urgency, nurtured by patience and stability rather than force. Let your thoughts drift slowly, like these early living patterns, supported by calm conditions and free from pressure. The oceans have fulfilled one of their deepest roles. They have not only cooled the planet and shaped its surface, they have created a space where life can begin softly, held in water, guided by time, and allowed to persist long enough to matter. As those earliest living patterns persisted within the oceans, something gently transformative began to unfold, because life did not remain separate from the water that held it, but instead became woven into the ocean's slow movements, its chemistry, and its rhythms, creating a quiet partnership that would shape the future of the planet. The seas were no longer just a setting where life happened to exist. They became an active participant in its continuation, guiding, buffering, and nourishing it through steady balance. Within the warm upper layers of the ocean, some of these early living systems learned to interact with sunlight, using its gentle energy to sustain themselves. Light filtered down through the water in softened layers, losing intensity with depth, creating zones where different forms of early life could exist without competition or disruption. Near the surface, faint illumination encouraged simple energy gathering. Deeper down, darkness and geothermal warmth supported slower, steadier processes. As these living systems interacted with their environment, they subtly altered the chemistry of the water around them. They absorbed certain compounds and released others, creating small gradients that spread outward through gentle diffusion and slow currents. Over long periods of time, these changes accumulated, influencing the composition of the oceans themselves. Life and water began shaping one another in quiet feedback, each responding to the presence of the other without force. The oceans continued to circulate slowly, carrying these living patterns across wide regions. Some drifted into warmer waters. Others settled into cooler depths. Those that remained stable under changing conditions persisted, while others dissolved back into simpler chemistry. This was not competition as we understand it today, but a calm filtering, where persistence was guided by harmony with the ocean's rhythms rather than struggle. Above, the atmosphere continued its gradual evolution, influenced indirectly by these processes in the sea. Gases released by early life dissolved into the water or escaped slowly into the sky, contributing to long-term changes that would eventually reshape the planet's air. These changes occurred so gradually that the planet never experienced shock or imbalance. Everything moved forward together: water, chemistry, and life in shared patience. Imagine the oceans during this era as vast, living fields, dark and deep, yet quietly active within. The surface remains calm, reflecting a softened sky, while beneath it countless tiny systems drift, adapt, and persist, carried by slow currents and guided by temperature and chemistry. There is no visible sign of transformation from afar, yet within the water the planet is changing in ways that cannot be reversed. The oceans continue to protect these early life forms from extremes. Sudden changes in temperature are absorbed. Chemical disturbances are diluted. Radiation from above is softened by layers of water. This protection allows life to remain fragile, yet enduring, able to exist long enough to develop further complexity without being erased. As you imagine this living ocean, let the idea of quiet cooperation settle into your thoughts. Feel how stability can nurture growth without urgency, how movement can occur without disruption, and how transformation can unfold gently over time. Let your breathing slow as you picture water and life moving together, each supporting the other in a shared rhythm. The oceans have now crossed a subtle threshold. They are no longer only shaping Earth's physical and chemical systems. They are carrying life within their depths, guiding it patiently through a calm world, preparing the planet for a future where water and living systems will shape one another ever more deeply. As the long story of Earth's oceans settles into its final, quiet rhythm, it becomes clear that these vast bodies of water were never merely a result of cooling rock and falling rain, but a continuous presence that gently guided the planet from chaos toward balance, from fire toward calm, and from silence toward light. The oceans did not arrive all at once, nor did they ever stop changing. Yet through every transformation they remained patient, absorbing, regulating, and holding the planet in a steady embrace. From the moment water first condensed and learned to stay upon the surface, the oceans began shaping Earth in ways that were subtle yet profound, smoothing extremes, calming violent forces, and allowing slow processes to unfold without interruption. They absorbed heat and released it gently. They carried minerals across vast distances, They softened the atmosphere and taught the sky how to breathe. Through this quiet labor, they created a world where stability was possible, not because nothing changed, but because change became slow enough to be gentle. As life emerged within their depths, the oceans did not demand adaptation through force. Instead, they offered protection, repetition, and consistency. They allowed fragile systems to persist long enough to learn how to endure. They diluted danger, buffered temperature, and provided a continuous rhythm that life could follow. In this way, the oceans became not only the birthplace of life, but its first shelter, a place where existence could unfold softly rather than struggle against extremes. Even as continents slowly rose and the surface of the planet began to change more visibly, the oceans continued their quiet work, shaping coastlines, driving climate, and carrying heat around the globe. They remembered the planet's past within their depths, storing warmth, chemistry, and emotion, releasing them gradually so that Earth never needed to rush into its future. Through cycles of light and darkness, through ages of calm and slow transition, the oceans remained constant in their presence. Imagine Earth now as it drifts through space, wrapped in deep blue water that reflects the softened light of the sun. The oceans move continuously, yet never urgently, guided by gravity, rotation, and gentle differences in temperature. Waves rise and fall, currents turn slowly, and beneath the surface, darkness and calm extend downward in layers that feel timeless and protective. As you hold this image, allow the idea of endless water to fill your awareness. Let thoughts become like gentle waves, forming and dissolving without effort. Let the steady presence of the oceans quiet the edges of the day, smoothing sharp moments into something softer and more distant. Feel the rhythm slow, not toward an ending, but toward a state of rest where movement continues without demand. The story of Earth's oceans is not a story that truly ends, because even now they continue to shape the planet, guiding climate, nurturing life, and holding the memory of everything that has passed. They remain a quiet force, vast and patient, surrounding the world with calm persistence. Let that persistence linger in your mind. Let the image of endless water soften your thoughts. Let the rhythm slow until it feels natural to rest within it. The oceans are still there, breathing gently around the planet, carrying Earth forward through time, steady and unhurried, like a lullaby that never needs to end.